In this video, we are going to go over acid-base homeostasis in blood. So the carbonic acid hydrogen carbonate buffer in blood is the primary blood buffer. The carbonic acid is the weak acid and the bicarbonate ion is its conjugate base. It is a combination reaction and it's reversible. The concentration of hydrogen carbonate in blood is regulated by the kidney, which release and absorb hydrogen carbonate as needed into circulation. When the concentration of dissolved carbon dioxide in the blood increases, the reaction shifts to the right to consume more carbon dioxide and produce more carbonic acid. Conversely, when the concentration of carbon dioxide in blood decreases, the reaction shifts to the left, a decomposition reaction, to produce more carbon dioxide and water. You can see we have a combination decomposition reaction between carbon dioxide and water to produce carbonic acid. Carbonic acid this carbonic acid is from the cells, and it can create hydrogen carbonate ions, which is regulated by the kidneys, the uptake of that, plus the hydronium ion. Carbonic acid is a component of both of these reactions, the composition-decomposition reaction and then the buffer system. A shift in the equilibrium of one reaction causes a shift in the same direction in the equilibrium of the other reaction. If you need to make more carbonic acid, then you need to shift the other reaction as well. So we can write it as kind of a two-step reaction. We have a carbon dioxide carbonic acid equilibrium, and then we have the carbonic acid bicarbonate buffer equilibrium. So if we add hydronium ions, it causes a shift to the left in the buffer equilibrium. The increase in carbonic acid increases, so the carbonic acid concentration increases, causing a shift to the left in the carbon dioxide equilibrium. And this increases the rate of the reverse reaction. Carbon dioxide increases, causing lungs to exhale more carbon dioxide. So adding hydronium ions right here reacts with hydrogen carbonate ions to produce more carbonic acid. So you add hydronium ion, it reacts with hydrogen carbonate, increases the rate of the reverse reaction to create more carbonic acid. If you increase carbonic acid, you're going to shift to the left of this second equilibrium and create more carbon dioxide. The lungs assist getting rid of this carbon dioxide by exhaling more carbon dioxide, causing a shift to the left in the carbonic acid decomposition reaction. This consumes some carbonic acid, causing further shift to the left of the buffer equilibrium. Eventually, the kidneys assist, if necessary, by releasing hydrogen carbonate into solution, which causes a shift to the left in the buffer equilibrium. Adding sodium hydroxide, it decreases the hydronium ion concentration and causes a shift to the right in the buffer equilibrium. The decrease in the carbonic acid causes a shift to the right in the carbon dioxide carbonic acid equilibrium, and the concentration of carbon dioxide decreases, causing the lungs to exhale less carbon dioxide. So the adding hydroxide consumes carbonic acid, so you're decreasing your H3O plus, causing a shift to the right, using up carbonic acid. If you're using up carbonic acid, then you're going to want to create more carbonic acid. So this reaction is going to shift to the right as well, and using up carbon dioxide and water. The lungs assist this by not exhaling as much carbon dioxide, because you need the carbon dioxide to create more carbonic acid. Acid-base homeostasis is maintained in the blood by buffers, regulation of breathing or lung ventilation, absorption and release of hydrogen carbonate ion by the kidneys. The lungs, through an increase or decrease in breathing rate, affect the concentration of dissolved carbon dioxide in the blood. The kidneys regulate the concentration of hydrogen carbonate in the blood, And together, the lungs and the kidneys support the carbonic acid hydrogen carbonate buffer to maintain this acid-base homeostasis. So acid-base homeostasis, we have different steps here. So when you exercise, during exercise, hydronium ions increase. So hydronium ions increase, causing a shift to the left, producing more carbonic acid, which creates more carbon dioxide, which is exhaled when you breathe. Kidneys support the shift to the left by releasing more hydrogen carbonate so that it can react with hydronium ions to keep the system going. The buffer equilibrium reaction shifts to the left to consume some of the added H3O plus to produce more carbonic acid. The lungs increase respiration and irreversibly remove the additional carbon dioxide produced. If required, again, the kidneys release more HCO3 plus to keep reacting with the increase of hydronium ions from exercise. Acidosis is a condition when the blood pH is greater, or less than 7.35. Respiratory acidosis is when your breathing is weak and shallow and carbon dioxide is not exhaled. It causes a shift to the right, so it increases the concentration of hydronium ions and therefore decreases pH, so makes it more acidic. It's caused by head injuries, emphysema, asthma, and narcotic use. There's metabolic acidosis, which is the kidneys do not release enough hydrogen carbonate to support normal shift to the left. This leads to increasing the hydronium ion concentration and makes it more acidic. This is caused by kidney failure, uncontrolled diabetes, or starvation. Alkalosis is when the blood pH is above 7.45. You have respiratory alkalosis, which is when rapid breathing removes too much carbon dioxide, which makes a cause of shift to the left, which decreases your H3O plus and increases your pH. This is caused by hyperventilation, which can be from anxiety, altitude sickness, intense exercise. Then you also have metabolic acidosis, or should be alkalosis. Kidneys do not remove enough HCO3 minus from the blood. And this causes a shift to the left, decreasing the H3O plus concentration and increasing the pH. This can be caused from excessive vomiting, see this in bulimics, excessive usage of antacids, and adrenal gland disease. So treatment of these for respiratory and metabolic acidosis, the treatment is an IV infusion of hydrogen carbonate to cause a shift to the left in this equilibrium balance. Respiratory alkalosis, you breathe into a paper bag to increase the blood carbon dioxide levels and shift equilibrium to the right. When you breathe into a paper bag, the concentration of carbon dioxide in that bag increases. So when you're breathing it back in, you're getting a higher concentration of carbon dioxide. Metabolic alkalosis is IV infusion to dilute hydrochloric acid. IV infusion of dilute hydrochloric acid, causing a shift to the right. So this will increase your hydronium ion concentration. So in summary, the primary blood buffer is the combination of carbonic acid and hydrogen carbonate. The acid-base homeostasis is maintained in the blood by buffers, regulation of breathing, so lung ventilation of carbon dioxide, and absorption and release of hydrogen carbonate ion by the kidneys. Together, the lungs and the kidneys support the carbonic acid hydrogen carbonate buffer to maintain acid-base homeostasis. Adding the hydronium ion causes a shift to the left in the buffer equilibrium, increases the rate of the reverse reaction, and causes lungs to exhale more carbon dioxide. Adding hydroxide ions decreases the H3O plus concentration and causes a shift to the right in the buffer equilibrium, increases the rate of the forward reaction, and causes lungs to exhale less carbon dioxide.